Hello and welcome. In this video, we're going to be looking at numerical integration, how to use it, and we're going to be looking at the midpoint, trapezoid, and Simpson's rule. Okay, let's start by saying we have a definite integral of x cubed dx, and we need to integrate from 0 to 8. I think this is simple, and after watching the video that I've done, you should be more than comfortable of solving this, and I will leave the definite integration video on the top right hand corner. So to do this, we can integrate normally, so it's going to be x power 4 over 4, and we will evaluate from 0 to 8, so this is going to equal, substituting my upper bound, which is 8 first, so it's going to be 8 power 4 over 4, and then subtracting when I substitute my lower bound, which is 0 power 4 over 4, so anything, so this whole term is 0. So this is going to give me an answer of 8 power 4 over 4 is going to equal 1024. And this is basically the area under the graph from 0 to 8. If we drew our graph, or this function, or at least the section from 0 to x equals 8, let's say here is 8, okay, what we found, the 1204, is basically this area under the graph. This is the normal definite integral. In today's video, we're going to be highlighting numerical integration. So let's say that our integration was not simple as x cubed. It was something very, very difficult, something I couldn't integrate, or I don't know how to, or it's going to take so much long time. Is there any way to approximate this definite integral? Yes, we will do numerical integration. So numerical integration is basically approximation of the area under the graph. So it's an approximation of the value of the integral. Okay, so let's see how we can do that. First of all, let's redraw our curve from 0 to 8. So it looks something like this. So the idea of numerical integration is I will divide this whole area into smaller rectangles. Okay, so let's say this rectangle over here, this rectangle over here, okay, and then another rectangle, another one, and so on until we have an approximation for our area. So we approximated our area. We will get the area for each of these rectangles. We have 1, 2, 3, 4, 5, 6, 7, around 7 rectangles, and we will get the area, and this will give me an approximation. Obviously, I can see that I have some extra areas over here, which will make my answer probably greater than 1024. But basically, this is the approximation that we are trying to do. So the first type that we're going to be looking at is called the midpoint rule. Okay, what does that mean? It means that, let's say we have our sketch once more. Okay, first of all, we need to know where is our lower bound and where is our upper bound. This is very easy. It's from 0 to 8, and we need to know into how many small rectangles do I want to divide this section. Do I want to divide it into only 2 rectangles, let's say? Okay, or do I want to divide it into 100 rectangles, 10 rectangles, 1 million? I need to choose. So let's say we are going to divide it into 4 rectangles or 4 intervals. Let's call the rectangles or intervals, let's give them a letter, let's call it n. So n equals 4. So we will divide it into 4 sections. Okay, so just something to note that as the number of rectangles, or basically as the value of n increases, the approximation accuracy increases. So we get closer to our exact value as n increases. Okay, so this is for you to note. Okay, so we will divide our section into 4 subsections. So let's say we have our number line. Let's say we have a number line. Okay, this is 0, this is 8. I'm going to divide into 4 subsections. So what is the length of each subsection? So let's say this is the first interval, second interval, third interval, and fourth. Let's make them a little bit equal. 1, 2, 3. So this length, and this length, and the final length should be equal, and we will call them delta x. Okay, so how to calculate delta x? It's very easy. Delta x is equal to b minus a, where this is b, this is a, over n. Okay, so delta x is going to equal 8 minus 0 over n, which is 4. So 8 over 4, so 2. So delta x is 2. So every single interval increases by 2. So if this is 0, then this is 2, 4, 6, and then this is 8. So the midpoint rule tells me that I will, okay, let's say this is 2, 4, 6, and 8. The midpoint rule tells me that I will take my rectangles at points in the midpoint of the interval. Okay, so let's say this interval over here from 4 to 6, I will go up, okay, until I reach my curve, and this is going to be the height of my rectangle. Let's say this one, I'm gonna go up till I reach the curve, and this is going to be the height of the rectangle. The widths of the rectangle are all going to be the same, and they're gonna be delta x, okay, but the height, I'm just taking it at the midpoint between every single interval. Okay, so how can we add the areas of these rectangles? So the total area is going to equal delta x, which is the width of this rectangle, let's say, multiply the height of this rectangle. So what's the height of the rectangle? The height of the rectangle is basically f of x. If this is, let's say this is x1, this is x2, this is x3. So for this rectangle, it's the y value evaluated at x3. So it is f of x3, right? So it's the width, which is delta x, multiply the height, which is the y value over here, which is the y value at which s? At x3. So it's f of x3, okay? And then we sum all of the rectangles. So this is basically the main idea of what we are doing here. So the midpoint rule, I'm going to give you the rule. The midpoint rule equals delta x. Let's take delta x out. Instead of saying delta x times f of x1 plus delta x times f of x2, I'm just going to take delta x out, and then I'm going to do f of x1 plus f of x2 plus f of x3, so on until f of x, the final x, let's call it n, okay? Basically. So this is the midpoint rule. So let's try to apply the midpoint rule to our original integration, which was this over here. So integration of 0 to 8 of x cubed dx. We have our n equals 4. That makes my delta x equals b minus a, which is 0, over n, which is 4. So delta x equals 2. So our midpoint rule is going equal to delta x, which is 2, multiply. Okay. Over here, this is my number line, okay? As I said, the midpoint rule, we take the points in the middle of the interval. So what is the point in the middle between 0 and 1? It's 1. So we will say that it's f of x, or f of 1, basically. F of 1 plus, what's this point? This is 3, so f3 plus the next point is f of 5 plus f of 7, right? So over here, I can say that this is equal to 2 multiply. Okay, what is f of 1? It's basically the function substituting 1 into x. So it's basically 1 power 3, which is 1. Plus, what is f of 3? It's basically 3 power 3, which is 27. And then f of 5, which is 5 power 3, which is 100. 1025 plus f of 7, which is 343. If we put these values in the calculator and then times 2, this is going to give you an answer of 992. So 992 and the exact value is 1024. They're not super far off. This is a good approximation, and as I said, if you increase the number of n, so if you increase n, if you make it 6, 10, 100, you will find an even closer value. So basically this is how to use the midpoint rule. There is another rule that is called the trapezium rule. It basically tells me that instead of taking multiple rectangles, okay, to fill up my area, I'm gonna take multiple trapezoids. Okay, so again, let's say n equals 4. So I will have, this is 0, 2, 4, and 6. So over here, I'm gonna have this trapezium, okay, and then over here, I'm gonna have another trapezium, and then let's do it with another color. Over here, I'm gonna have another trapezium, and can you see that this, in this case, could give me a more accurate answer? So I will have another trapezium over here. So I will have 4 trapeziums, and now I will need to add up the areas of those 4 trapeziums. Okay, if I have, let's say, let's take this trapezium over here. Let's move it outside so it looks something like this. This side is A, this is B, and this side is H. The area of a trapezium is equal to A plus B over 2 times H. Okay, so what is A over here? A is basically this length, or the y evaluated at x equals 4, right? So if this, let's call this point x0, this is x1, this is x2, this is x3, and this is x4. So this green trapezium will have an a value of f of x2 plus a b value of f of x3 over 2 times h. Okay, what is h? H is basically delta x. Delta x. So this is the area of one single trapezium, and now I will need to combine the areas of all the trapeziums. Okay, so let's take the next trapezium and add it. I will find that I will have, okay, this trapezium now is going to be delta x over 2. I'm just going to take this delta x over 2 outside, multiplying f of x3 plus f of x4, right? So I can see that from here I can take delta x over 2 out, and then I will multiply it with this side is going to repeat 2 times. This side is also going to repeat 2 times. As we saw here, f of x3 and f of x3 is repeated 2 times. Why? Because it's going to be used in this trapezium and in the next trapezium. They share the same side. But which sides are not shared by 2 trapezium? We have 2 sides. The first side over here is only in this trapezium, and the last side, right? So that is why the trapezium rule is going to equal delta x over 2 times f of x0. So that's the first x, plus 2 times f of x1 plus 2 times f of x2, and then plus so on until we reach f of 2 times f of x n minus 1, so the x just right before the last one, and then plus f of xn. So as we said, the first side, which is f of x0, and the last side, which is this side over here, do not repeat 2 times. That's why they're not multiplied by 2. However, every single side is repeated 2 times. So the trapezium rule is basically delta x over 2 multiplying f of x0 plus 2 times f of x1, and we keep on going, multiplying 2 each time. And then when we reach the final f of x, we do not multiply by a 2. So this is the trapezium rule. Let's try to apply it for our same problem. So it's integration from 0 to 8 x cubed dx, n equals 4. So again, if n equals 4, delta x is going to be the same, is going to be equal to 2, because we have the same b, the same a, the same n. Okay, and let's try and do that now. So delta x, 2 over 2, multiplying f of x 0. So if we do our number line again, 0, this is 8, delta x is 2, so 2, 4, 6. So f of x 0 is basically 0. So f of 0 plus 2 times f of x1 is basically this point. So f of 2 plus 2 times f of the next point, which is 4, plus 2 times f of 6 plus f of 8, because this is the last point. So 2 over 2 is basically 1, so this is equal to f of 0 is basically, again, evaluating 0, so at x power 3, so this is going to be 0 power 3, which is 0, plus 2 times f of 2, so 2 power 3 is 8, so it's 2 times 8, plus 2 times f of 4, 4 power 3 is 64, plus 2 times f of 6, so 6 power 3 is 216, and then plus f of 8, 8 power 3 is 512. So from here, you can see that the answer is basically 1088. It's also an approximation. It's not the exact value, but you can see that this is also another way to estimate or approximate the value of the area under the curve. Okay, the last rule is going to be the Simpson's rule, and it goes like this. Simpson rule's formula is equal to delta x over 3 multiply f of x0 plus 4f of x1 plus 2f of x2, and then plus we keep on alternating 2 and 4. So the first term has no coefficient, okay? The next term is 4, and we keep alternating 4, then 2, then 4, then 2, then 2, then 4, then 2, then 4, then 2, until we reach to the one just before the last term. It's going to be 4 times f of x n minus 1, and then plus the last term, similar to the trapezium rule, it's just f of xn. So let's try and do that to the same problem that we had. So delta x was equal to 2, n was equal to 4, our number line was 0, 2, 4, 6, and 8. So this is going to be 2 over 3, delta x is 2 over 3, times f of x0, so 0 power 3 is 0, plus 4 times f of x1, so this point over here, the next point, so 2 power 3 is 8, plus 2 times f of 4, so 4 power 3 is 64, plus I will keep alternating. So this is 4 times f of 6, so 6 power 3 is 216, plus the last term goes in without any coefficient, so it's just f of 8, which is 8 power 3, which is 512. And as we can see, the second to last term, which is the term just before the last one, has a coefficient of 4, and this is a must. And if we put this in the calculator, we will get an answer of 1024, which is an exact approximation. this says that the Simpson's rule is the best one in this specific case. This is not always the case. However, usually Simpson's rule is the most accurate one. Okay, so let's take some examples. Okay, try and solve them together. Let's say we have a problem saying we have the integration from 1 to 4 of square root of ln x dx, okay, and we are required to divide it into 6 intervals, so n equals 6. So how do we do this? And we're required to estimate it using the midpoint, trapezium, and Simpson's rule. So let's start by first finding our delta x. Delta x is b minus a, which is 1, over n, which is 6, so it's basically 3 over 6 or 1 over 2. So the next thing is to do our number line. We start from 1, we end at 4, and we have a jump of half, or 0.5. So this, let's actually elongate this a little bit. So this is 4, this is 1, we have this point over here is going to be 1.5, 2, 2.5, 3, 3.5, and then 4, and this is how we divided it into 1, 2, 3, 4, 5, 6 equal intervals. So let's start using the midpoint rule. So the midpoint rule tells me that I'm going to evaluate at not the exact points, but the midpoints between those points. So let's start by doing that. So what's the midpoint? What's in the middle between 1 and 1.5? It's basically 1.25. What's in the middle between 1.5 and 2? It's 1.75. And let's do the same for the rest. This is going to be 3.25, and this is 3.75. So our midpoint rule tells me that it is delta x, okay, which is half, or 0.5, multiply f of x1, the first x, which is evaluated at 1.25, so f of 1.25 plus f of 1.75 plus f of 2.25 plus f of 2.75 plus f of 3.25 plus f of 3.75. So over here, I'm going to do 0.5, open bracket. What is f of 1.25? If I want to calculate that, I will need to substitute 1.25 into this x over here. So this is going to equal square root of ln of 1.25. And this is going to give me an answer of around 0.472. And so this is over here is 0.472. And I'm going to do the same for the rest. So the second one is going to be ln of square root of ln of 1.75. This is going to give me 0.748, and then plus 0.901 plus 1.006 plus 1.086 plus 1.15. And evaluating this is going to give me an answer of 2.681. This is going to be the answer using the midpoint rule. So let's do the same question, but for the trapezium rule. So we have the same exact things over here. Okay. However, the trapezium rule is equal to delta x over 2, so 0.5 over 2, times f of the first x now, which is f of 1. F of 1 plus 2 times f of 1.5 plus 2 times f of 2 plus 2 times f of 2.5 plus 2 times f of 3 plus 2 times f of 3.5, and then plus f of the last point, which is 4. Okay, so if I want to get f of 1, I'm just going to evaluate square root ln of 1. This is going to give me an answer of, okay, 0.5 over 2 is basically 0.25 times. F of 1 is basically 0 because ln of 1 is going to be 0, plus 2 times f of 1.5 is 0.637. I'm going to do the rest the same exact way. 3 this is going to be 2 times 0.957 plus 2 times 1.048 plus 2 times 1.119 plus f of 4. So basically square root of ln of 4 is going to be 1.177, and this is going to give me an answer of 2.616. So over here we can see that they're very close to each other. And finally, let's use the Simpson's rule to try and solve. So Simpson's rule is going to equal delta x 0.5 over 3 times, okay, f of 1 plus 4 f of 1.5, and then I'll keep alternating, so 2 f of 2 plus 4 f of 2.5 plus 2 f of 3 plus 4 f of 3.5, and then when I reach the final one I will need to write it as f of 4 without any changes. So this over here is going to equal 0.5 over 3 multiply f of 1 again is 0 plus 4 times f of 1.5, which is 0.637 plus 2 times 0.833 plus 4 times 0.957 plus 2 times 1.048 plus 4 times 1.119 plus the last one is 1.177. And if we evaluate this, we will find that the answer is going to equal 2.6318. And for this question, the exact answer is equal to 2.6614. So over here we can see that the closest answer was actually using the midpoint rule, which gave an answer of 2.68. This was 2.61 and this was 2.63. So the midpoint rule for this one is the best approximation. So let's take an example which is interesting, because we don't always need to use the Simpson's rule or the numerical integration in questions that are difficult to integrate. Sometimes there is no function. It will just give you a table and we will need to find the definite integral. Let me show you how this is done. Okay, let's say we have this question. The table shows values of a force function, f of x. Okay, so this is the force, okay, as a function of x. So when x was 0, the force was 9.x. When x was 3, the force was 9.1, and so on. Where x is measured in meters and f of x is in newtons, use Simpson's rule to estimate the work done by the force moving an object of distance 18 meters. So work is equal to force times distance. Okay, this is force and this is distance. So the work is equal to the total of these things multiplying each other. So in other words, if let's say this, I graphed this graph, so this is f of x, this is x, okay? So the first point is 0 and 9.8, the second point is 3 and 9.1, and so on. I will find a graph probably that looks like this, and I will need to evaluate it from 0 to 18. I know the area under the graph is basically y times x, or f of x times x, which is force times distance, which is work. So what I'm trying to say is that the area, if we got the area under the curve, this is going to equal to the work. So to get the area under the curve, we need to integrate from 0 to 18. However, over here, unlike the previous question, we don't have a function to integrate, right? So that's why it said use the Simpson's rule to estimate the work done. Let's see how we can do that. First of all, how many intervals we have here? First, this is an interval, so 1, 2, 3, 4, 5, and 6. So n equals 6. My a is 0, okay, and my b is 18. So from here I can find delta x is going to equal b minus a over n. So 18 over 6, which is 3. So delta x is 3. And I know that the Simpson's rule equals delta x over 3 multiply f of x0 plus 4 f of x1 plus 2 f of x2 plus so on until 4 f of xn minus 1 plus f of the final x, which is xn. So from here, let's try to solve. So delta x is 3, so this is going to equal 3 over 3 multiplying. What is f of x0? So it's f of 0, right? Plus 4 times f of the second x, okay, which is 3, plus 2 times the third x, which is 6. I'm going from here. This is the first x, second x, third x, plus 4 times f of 9, plus 2 times f of 12, plus 4 times f of 15, plus the final one, which is f of 18. Okay, so from here, 3 and 3, they cancel, and I will just have f of 0. What is f of 0? It's basically the function evaluated at x equals 0, which is basically this number over here, because when x equals 0, the corresponding value was 9.8. So f0 is basically 9.8 plus 4 times f of 3 is 9.1 plus 2 times f of 6 is 8.5 and so on. So plus 4 times 8 plus 2 times f of 12, which is 7.7 plus 4 times f of 15, which is 7.5 plus the last one, which is f of 18, which is 7.4. So from here, I can put these values on my calculator, and this is going to give me an answer of 148. And since this is work, the unit is supposed to be joule. Because F is in Newton, X is in meters, so work is going to have joules as the unit. So from here, you can also use the Simpson's, midpoint, or trapezium rule to solve questions where we don't even have a function, or when we have a function that's super difficult to integrate, or you just want to have an approximation. I hope this video was helpful. Thank you so much for watching. Please don't forget to like, subscribe, and leave a comment down below. Ask me any questions. Feel free to do so, and watch the previous videos. Thank you for watching and have a nice day.